Hi, I'm Bill Reese, and in this video, we're going to take a look at the spreadsheet that is titled Maximizing Utility, and it uses one risky asset and the risk-free asset and shows us how if we know the expected return on the risky asset and its standard deviation, and we know the rate of return on the risk-free asset, and we know our utility function with the coefficient of risk aversion, we can find out what is the optimal combination of the risky asset and the risk-free asset to be able to maximize utility for our investor. This is going to be the point on the capital allocation line where the indifference curve is just tangent to the capital allocation line. So we're going to see how to do that in Excel. So let me do a screen share here with this spreadsheet. We'll pull it up here. And so you should be seeing it on the screen share here. And so let's start out by putting the weight at 100% on the risky asset to begin with. And so we actually don't see the solution right there to begin with. So here's what we're doing. The risky asset has an expected return of 22%. We've typed that in. This is the risky asset that was used in the example in your class notes. And the expected return or the rate of return on the risk-free asset is 5%. The standard deviation of the risky asset is 34.29%. And of course, the risk-free asset has a standard deviation of 0. That's our definition of a risk-free asset, has a standard deviation of 0. So right now, we're putting 100% of our money into the risky asset. That's what we're going to get Solver to change. Now, whenever we change the weight on the risky asset, it will automatically change the weight on the risk-free asset because as you can see up here, the weight on the risk-free asset will be 1 minus the weight on the risky asset. Now, our expected return on our portfolio right now is the same as the expected return on the risky asset because all of our money is in the risky asset. So, but this is formula one, which is, or equation one, which was the weight on the risky asset times the rate of expected return on the risky asset plus the weight on the risk-free asset times the risk-free rate. That gives us, that's equation one that gives us the expected return on the portfolio. The standard deviation of the portfolio, this is equation two. It's going to be the weight on the risky asset times the standard deviation of the risky asset. That gives us our standard deviation of the portfolio. Here is where we've entered in the coefficient of risk aversion for our investor. I've set this up as 3. And here is our utility function, the quadratic utility function that we have been looking at, which is going to be equal to the expected return on the portfolio minus 1/2 times A, that's referencing our A over there, times the standard deviation of the portfolio squared. So what we want to do is we want to say, hey, what needs to be the weight on the risky asset that will maximize this utility? If we have less than 100% of our money on the risky asset, will that maximize it? If we have more than 100%, will that maximize it? What exactly is it? And what Solver does is it very quickly tries out all different weights on the risky asset and finds the one that gives the highest level of utility. So to get to Solver, we go to Data, okay, and then we hit Solver, and we got Solver being brought up here, and this is already set to what we want to do. Our objective cell here is the utility. That's what we want something to happen to. We want to maximize it, right? So we want the maximum amount of utility, and we want to get that by changing the weight on the risky asset. So we're telling Solver, change the weight on the risky asset around to get the maximum amount on there. Now, make sure that you do not have this particular box here checked off. If you do, it says, hey, we're not going to allow for any negative values. There may be some times where we don't want to allow for negative values, but generally we do. And if we don't want to allow for negative values, a better way to do it is with constraints, where you actually type in the constraints. Because what happens if you check this off, you'll forget it's checked off, and then later on it won't allow for negative values when you do want to allow for negative values. So how can you do that with constraints? Okay, if you want to do it with constraints, you do something like this. We say that cell B6, okay, is going to be less than or equal to 1. Well, what's cell B6? That's the weight on the risky asset. And cell B6 has got to be greater than or equal to 0. So for example, let's suppose I wanted to get rid of this constraint. I'm going to delete it right there. All right, so it's no longer there. Now I want to put it back in. I'm going to put in add. And so it's going to say, what is cell reference that I want to constrain on? Right there. And it has got to be greater than or equal to 0 right there. And I hit OK. And now it's in there as a constraint. So that will, now we know that this is a non-binding constraint. Okay, these are both non-binding constraints. We know what the answer is going to be already because we got it in the class notes. So it's going to be between 0 and 1. But this is how you would put that in as a constraint. So now we want Solver to find for us the optimal weight on the risky asset, which will then also tell us the optimal weight on the risk-free asset in order to maximize our utility. We hit solve here, and just like that, we've got an answer, and we hit OK, and there it is. If we put 48.19% of our money in the risky asset, that means there will be 51.81% of our money in the risk-free asset, right? They got to add up to be 1. The expected return on the portfolio is 13.19%. The standard deviation on that portfolio is 16.53%, and the amount of utility is 9.10%. And Solver is telling us you can't get more utility than that. Okay, if you change the weight on the risky asset, whether you make it higher than that or lower than that, no matter what you do, it's going to result in less utility than 9.10%. So this is going to be the optimal weight on the risky asset to be able to maximize utility. This is going to be where on the capital allocation line our investor chooses to be. So you can change this around, this particular spreadsheet, to change the level of A for the person. You can change the expected rate on the risky asset. You can change the risk-free rate. You can change the standard deviation on the risky asset. And then Solver will solve for you what is the optimal weight on the risky asset. And you can see it's got a whole lot of decimals there. It's just rounded to 48.19%. And then this is going to be the weight on the risk-free asset, 1 minus that. Okay, so hopefully this will help you to be able to work with this particular spreadsheet here.